We're going to go over how to solve a system of equations using substitution today. Now, first of all, a system of equations is when you have equations that share the same variable. And when you're solving it, you're trying to figure out what each variable represents. What's the value? So we'll start out with a pretty basic one here, number 21. Now you notice we start out with y equals 5, and then we also have negative x plus y. Now using substitution, your goal is that you want to have a variable isolated in one of your equations. Luckily we already have that here with y equals 5. Now to solve using substitution, you're going to use the value that is given here and substitute it into the other equation. So since we know y equals 5, I've got negative x plus y equals 1 here. Now I'm going to substitute the y here with 5 since we're told that y equals 5. So I'm going to do negative x plus 5 now equals 1, which will allow me to solve for x. So I just solve it like a multi-step equation. Subtract 5 on each side. I get negative x equals negative 4. Now, a lot of people would be tempted to just leave it because they're thinking, oh, x is all alone. X isn't alone. You want to figure that if there's a negative here, you can put a 1 here. Identity property says you can multiply anything by 1. It's not going to change. So I'm going to pop that 1 in there. Divide each side by negative 1. And I get x equals positive 4. You would think I am done. However, I am not done yet. I want to double check to make sure this works. So I'm going to plug it in to one of my equations here. Now the only one that has x and y is this one right here. So I'm just going to double check it. So negative x plus y equals 1. I'm going to substitute my values. So negative, I got 4 for x, 4, plus I got 5 for y equals 1. 1 equals 1. Hey, it checks. So my solution for this now, I can make an ordered pair out of it. My x value is 4. My y value is 5. So that's an easier way. That's an easier one. Now, you might have a situation like let's go with 25 here. 25 is a little more difficult, and I'll show you how you can do this. Now, you have a couple of options. We have y isolated in both cases here. We have y equals 2x minus 5. We have y equals x plus 8. We don't have a specific value for y, but we do have an expression. What I'm going to do is I'm going to substitute one of these expressions. So I have y, I'm going to use this one here because it's a little less intense. I get y equals x plus 8. So I do have a value for y. Because I know not only does y equal x plus 8, y also equals 2x minus 5. So what I can do is I can substitute that for y. So I'm going to put in 2x minus 5, and I also know that that's going to equal x plus 8. So now I can just solve each side. Now my goal is I want to get the x alone. So to get all my x's to one side, I'm going to get rid of this x. Subtract it over here. Got to do it on the other side as well. And since I don't have a value there, I can put a 1 here. I don't have that coefficient. I gave it 1. Now I have x minus 5 equals 8. Solve each side. Add 5. I get x equals 13. However, I am not done. I still have to figure out what y is going to equal. In order to do that, I can substitute my x value into any of these equations. I'm going to go with this one here, y equals x plus 8. Why? Because it's a bit easier. It's a lot less intense than the other one. So y equals x plus 8. I'm going to substitute my x value now for x. So I'm going to have y equals 13 plus 8, which enables me to solve for y pretty easily. Y equals 21. So my final solution for this would be 13, 21 is an ordered pair, x and y. So that is just a brief introduction, to how to solve a system of equations using substitution. I'm going to post another video going through another example of this. So if you're having a little trouble, feel free to watch my next video.